You are awake. Right now, you are aware of these words on the screen. You might feel the chair you are sitting on. You can hear a faint noise in the background, maybe a fan or traffic. You have a sense of yourself, a feeling of being you, located somewhere behind your eyes. You have memories, hopes, and a nagging thought about what to have for dinner. This inner world, this private movie that only you can see, is consciousness. It is the most familiar thing in the world, and it is the biggest mystery in the universe. Where does it come from? This question is not like other questions. It's not like asking where mountains come from. We can explain that with geology and plate tectonics. It's not like asking where life comes from. We can explain that with biology and evolution. This question is different. It's about the feeling itself. Why does all the buzzing and firing of neurons in your brain feel like anything at all? This is what some philosophers call the hard problem. The easy problems are things like, how does the brain process light from your eyes so you can recognize a face? How does it send signals to your legs so you can walk? These are incredibly complex problems, but they are problems of function. We can imagine, in theory, building a machine that does all of that. We can see a path to solving them with more research and better technology. But the hard problem is about experience. Why is there a feeling of redness when you see a ripe tomato? A robot could be programmed to identify the wavelength of red light, say the word red, and even pick the tomato. But does it have the inner experience of redness? We assume it doesn't. So why do we? Why aren't we just complex biological robots processing information in the dark without any inner life? That's the core of it, the gap between the physical world of brain cells and electricity and the private, subjective world of feelings, colors, and sounds. For centuries, we thought this was a question for priests and philosophers. Now, scientists are trying to crack it too. And they have some ideas. The most straightforward idea is that consciousness comes from the brain. It has to. Where else could it be? People with brain injuries can lose parts of their consciousness. Anesthesia, which affects the brain, can turn it off completely. Everything points to the 3-pound lump of tissue inside our skulls as the source of the magic. But saying it comes from the brain is like saying a novel comes from a printer. It's true, but it doesn't tell you anything about the story, the characters, or the author. The real question is how. How does the brain do it? One early idea was that there was a special spot in the brain where consciousness happened. It's a sort of command center. The philosopher René Descartes thought it was the pineal gland, a tiny structure in the center of the brain. He thought it was where the non-physical soul connected with the physical body. We now know that's not right. The pineal gland just helps regulate sleep. Modern neuroscience has shown us that there is no single spot. There is no little person inside your head watching a screen. Consciousness seems to be a distributed process. It involves vast networks of neurons firing in sync across different regions of the brain. When you see a bird, your visual cortex lights up. When you hear it sing, your auditory cortex gets involved. When you recognize it as a robin, your memory centers chime in. Consciousness is the act of all these areas working together, binding information into a single, unified experience of a robin is singing outside my window. Scientists are trying to find the exact patterns of this brain activity. They call it the neural correlates of consciousness. The idea is simple. Let's find what is happening in the brain at the exact moment a person becomes conscious of something. They do experiments. They might show a person a picture, but flash it so quickly that sometimes the person sees it and sometimes they don't. Using tools like fMRI or EEG, scientists watch the person's brain activity. When the person reports seeing the picture, what's different in their brain compared to when they don't report seeing it? What they found is that when a person becomes conscious of something, the brain activity isn't just localized in one sensory area. Instead, the signal seems to spread. It ignites a widespread network, particularly in the prefrontal cortex, the part of the brain associated with planning and higher thought, and the parietal lobe, which helps integrate sensory information. This has led to one of the leading scientific theories of consciousness, called the Global Workspace Theory. Think of the brain as a massive organization with thousands of employees working in separate departments. Most of their work is done quietly, unconsciously. They process payroll, manage supplies, and keep the lights on. This is like the vast unconscious processing happening in your brain all the time, regulating your heartbeat, balancing your posture, and making sense of raw sensory data. But when a piece of information is really important or novel, it gets sent up to the executive suite. It's put on a central stage or workspace where it is broadcast to the entire organization. All the department heads can see it and use it to inform their own work. According to this theory, consciousness is what happens when information gets broadcast to this global workspace. This is the moment something becomes available to your memory, your language centers, and your planning systems. It's the moment you can think about it and report on it. It's the moment it enters your conscious awareness. This theory is appealing because it's practical. It gives us something to look for in the brain, a widespread ignition of neural activity. It explains why we can only be conscious of one or a few things at a time. The stage has limited capacity. It also makes sense from an evolutionary perspective. A global broadcast system is a great way for a complex system to coordinate its actions and focus on what's most important. But there's a problem. The global workspace theory is another easy problem theory. It's a theory about how information is managed in the brain. It explains how we access and report on information. It doesn't explain why broadcasting that information on a mental stage feels like anything. It's still a theory of function, not a theory of experience. Why isn't it all happening in the dark? Another major theory tries to get a little closer to the feeling itself. It's called Integrated Information Theory, or IIT. It starts not with the brain, but with consciousness itself. It asks, what are the essential properties of conscious experience? One property is that it's incredibly informative. Your current conscious state is one out of trillions of possible states. Just look around the room. The specific arrangement of colors, shapes, and sounds you are experiencing is unique. It rules out countless other possible experiences. Another property is that it's unified or integrated. If you don't experience the red of a ball separately from its roundness or its motion, you experience a single unified red ball. All the information is bound together. IIT proposes that anything with these properties and information and integration has a degree of consciousness. The theory even offers a way to measure it. The measure is called phi, and it represents how much a system's whole is more than the sum of its parts. A system has high phi if it has many possible states. High information and its parts are all highly interconnected in a way that you can't break it down into smaller, independent components, high integration. According to this theory, the human brain, with its billions of neurons and trillions of connections, is a structure with an incredibly high phi. That's why we have such rich conscious experience. A simple photodiode, which can only be on or off, has very little information and no integration. Its phi is basically zero. It's not conscious. This theory is fascinating because it treats consciousness not as an all or nothing property, but as a spectrum. A mouse with a less complex brain would have a lower phi than a human, but still a significant amount. An octopus might have a high phi. Even a complex computer circuit could, in principle, have some level of phi. This leads to a radical conclusion. IIT suggests that consciousness is not limited to biological brains. It's a fundamental property of any system with the right kind of structure. This idea that consciousness might be far more widespread in the universe than we thought is called panpsychism. We'll come back to that. The big problem with IIT is that it's incredibly hard to test. Calculating phi for anything as complex as a human brain is currently impossible. It's also a bit strange. It tells us that a certain kind of information structure is consciousness, but it still doesn't fully bridge the gap and explain why that structure should feel like something. It's like describing the mathematical structure of a joke, but not explaining why it's funny. A third perspective from neuroscience is the idea of the brain as a prediction machine. This is sometimes called predictive processing or the Bayesian brain. The idea is that your brain isn't passively receiving information from the senses. That would be too slow and inefficient. Instead, your brain is constantly, actively, and unconsciously making predictions about what it expects to see, hear, and feel next. Your brain builds a model of the world based on all your past experiences. This model generates predictions. What you consciously perceive is not the raw sensory data coming in. It's your brain's best guess about the cause of that data. Sensory information is mostly used to check the predictions and update the model when there's an error. For example, you don't actually see every single detail of the room you're in. Your brain predicts it's there based on your memory of it, and you only become consciously aware of something if it violates that prediction. Like if a book on your shelf suddenly moves. Most of the time, you are just living inside your brain's simulation of the world. In this view, consciousness is tied to this process of prediction and error correction. It's the experience of your internal model of reality being constantly updated. It explains things like optical illusions very well. The illusion works because it tricks your brain's predictive model. It also explains why the world feels so stable and coherent, even though the data from your eyes is a jerky, blurry mess as they dart around. Your brain smooths it all out based on its predictions. But again, we hit the same wall. Why does the process of updating a predictive model have to feel like anything? Why isn't it just a silent calculation? These brain-based theories are powerful. They are making real progress in understanding the mechanics of the brain. But they all dance around the central mystery of experience. This has led some people to think that maybe we're looking in the wrong place. Maybe consciousness isn't something the brain produces, like a stomach produces acid. Maybe it's something more fundamental. This brings us back to panpsychism. It sounds strange at first. The idea is that consciousness is a basic property of matter, right down to the level of an electron or a quark. Everything in the universe has some tiny, primitive form of experience. An electron doesn't think or feel sad, but it might have a minuscule spark of raw awareness. According to this view, brains don't create consciousness out of non-conscious matter. That would be like magic. Instead, brains act as a kind of amplifier or resonator. They take the simple primitive consciousness that's already everywhere and organize it, integrate it, and build it up into the complex, rich inner world that we experience. The hard problem of how consciousness arises from dead matter just dissolves. It never did. It was there all along. The new problem becomes the combination problem. How do all these tiny little bits of consciousness in atoms and neurons combine to form a single, unified consciousness like yours? How do you get one big mind from a trillion tiny minds? No one has a good answer for that. But panpsychism is taken seriously by a number of philosophers and even some scientists because it seems to avoid the magical leap from non-feeling stuff to feeling stuff. It keeps everything on a more level playing field. Another way to think about it is through the idea of emergence. Consciousness could be an emergent property. An emergent property is something that appears in a system but is not present in its individual parts. Think of water. A single molecule of H2O is not wet. It doesn't have the property of wetness. But when you get a huge number of H2O molecules together, the property of wetness emerges from their interactions. Think of a traffic jam. A single car cannot be a traffic jam. A jam is a property that emerges from the interactions of many cars. So maybe consciousness is like that. A single neuron is not conscious. It's just a little biological machine. But when you connect 86 billion of them in the right way, the property of consciousness emerges. The feeling of being you is the traffic jam of your brain. This sounds plausible, but there's a catch. With wetness and traffic jams, we can understand how they emerge. We can trace the causal links from the low-level parts to the high-level property. We can see how the interactions of water molecules lead to surface tension and viscosity, which we call wetness. With consciousness, we can't. The leap from firing neurons to the feeling of pain or the experience of the color blue still seems magical. It's not clear why that specific pattern of interaction should create a subjective feeling, while other complex patterns, like the weather system of a planet or the workings of the internet, presumably don't. It's what some call strong emergence, a property that is genuinely novel and cannot be fully explained by its underlying parts. And to many scientists, strong emergence sounds a lot like giving up and just saying magic happens. Then there are the even more speculative ideas. Some thinkers, like the physicist Roger Penrose and anesthesiologist Stuart Hameroff, have proposed that consciousness comes from the strange world of quantum mechanics. They argue that classical physics and biology are not enough to explain the mystery of consciousness. Their theory, called Orchestrated Objective Reduction OR, suggests that consciousness arises from quantum processes happening inside tiny structures within our neurons called microtubules. In the quantum world, particles can exist in multiple states at once, a state called superposition. The theory proposes that quantum computations happen in these microtubules. Each time this quantum state collapses into a definite, classical state, a moment of conscious experience occurs. This is a wild idea. It links our very existence to the fundamental fabric of reality at the quantum level. It's also highly controversial. Most neuroscientists and physicists don't think it's plausible. They argue that the brain is too warm, wet, and noisy for such delicate quantum effects to survive for any meaningful amount of time. They believe these quantum states would decohere or break down almost instantly. But the theory persists because it's one of the few that tries to explain the specific qualities of consciousness, like its non-computable nature and the feeling of the passage of time. It's a bold attempt to find a new kind of physics to solve the hard problem. So where does this leave us? We have a collection of theories, each pointing in a different direction. The neuroscientists say it's all about complex networks and information processing in the brain. They are building a detailed map of the brain's functions, hoping that once the map is complete, the mystery of experience will somehow be explained. The philosophers and panpsychists say the scientists are missing the point. They argue that you can't get experience from function alone. You have to start with experience as a fundamental part of the world. The physicists on the fringe say both groups are using the wrong tools. They believe the answer lies in a deeper understanding of reality and the strange rules of quantum mechanics. It's possible that one of these is right. It's also possible that they are all wrong. Maybe consciousness doesn't come from anywhere in the way we usually think. Maybe it's a feature of reality we just don't have the concepts to grasp yet, like a fish trying to understand the concept of the sky. And what about the purpose of it all? Why did we evolve this strange inner movie? Does it actually do anything? The common sense answer is yes. Of course it does. I consciously decide to lift my arm, and my arm lifts. My conscious feeling of pain causes me to pull my hand away from a hot stove. It seems obvious that consciousness is in the driver's seat, but some scientists and philosophers are not so sure. There's a view called epiphenomenalism. It suggests that consciousness is just a byproduct. It's like the heat coming off a computer's processor. The computations are the important thing that makes the computer run. The heat is just a side effect that doesn't do anything itself. In this view, all the work is being done by our unconscious brain processes. The brain activity that causes you to pull your hand away from the stove also, separately, creates the feeling of pain. But the feeling of pain itself doesn't cause anything. It's just along for the ride. You are not the driver. You are the passenger, watching the movie of what your brain is already doing. This is a deeply unsettling idea. It goes against our most basic intuition about ourselves and our free will. But there is some evidence for it. Experiments have shown that brain activity corresponding to a decision can be detected seconds before the person is consciously aware of having made the decision. It's as if the brain decides first and our consciousness is informed later. So after all this, the question remains, where does consciousness come from? The honest answer is nobody knows. We are living in a fascinating time. We have tools to look inside the working brain that were unimaginable a generation ago. We have brilliant people attacking the problem from every possible angle. But we are still at the very beginning. We are like ancient explorers standing at the edge of a vast unknown continent with only a few rough maps of the coastline. The mystery of consciousness is not just a scientific puzzle. It touches everything we care about. Our understanding of consciousness shapes our beliefs about free will, our ethical treatment of animals, our approach to artificial intelligence, and our experience of being alive. If an AI becomes complex enough, could it become conscious? How would we even know? If it says it has feelings, can we believe it, or would it just be a sophisticated mimic, a philosophical zombie with no inner life? Our current theories don't give us a clear way to answer that. What about a patient in a coma? If their brain shows complex integrated activity, do they have some form of consciousness even if they can't communicate? For 20 IT might suggest they do. These are not abstract questions, they have real-world consequences. Perhaps the biggest thing the search for consciousness teaches us is a sense of humility. It reminds us that there are profound limits to our current understanding of the world. We are a part of the universe that has woken up and is now trying to figure itself out. The fact that you are having an experience right now is a brute fact of your existence. You can doubt anything else. You could be in a simulation. Your memories could be false. But you cannot doubt that you are experiencing something. This raw awareness is the starting point for everything. And maybe the answer to where it comes from is not a neat, simple explanation. Maybe consciousness isn't an it at all. Maybe it's not a thing that a brain makes. Maybe it's a process. Maybe it's a relationship. Maybe it's a fundamental aspect of existence that we are simply a part of. We are left with the mystery. And in a world where so much is explained, categorized, and commodified, living with such a profound and personal mystery might be a gift. It keeps us curious. It keeps us searching. It forces us to confront the strange and beautiful reality of our own minds. The feeling of being you right now is the frontier of human knowledge, and the exploration has just begun.